The space-time diagram for space station S shows the world lines of two clocks. Each clock is 2 kilometers from S. The space-time diagram also shows the world lines of spaceship A. Question AI outline how clock 1 and clock 2 can be synchronized with the clock on S. And we can do that if we place light source midway between clocks at origin and set clocks at 2000 over C, just the time required a light to travel from the origin to each clock, and start them with flash of light from the origin, or initially together. It means clocks to be together at the origin and synchronized, just switched on at the same moment of time, and then just moves them infinitely slowly, very slow. Why very slow? Because relativistic effects will be negligible. Then determine in terms of C the speed of A in the reference frame S. So it's just tangent of the angle theta, or if it is given x prime, the theta is also here. Tangent theta is equal to V over C, and just from the diagram you can see the tangent, it's what, 2 over 8, it's 1 over 4, so V is 0.25 C. The next. Clocks emit separate light signals when A is at the origin. Identify on the diagram the proper time that elapses between the arrival of the light signals at A. So we know that light travels at speed of light, and again due to the tangent to be 1, so it's also called a light cone. And if it's about light, we draw lines at 45 degrees, and since it's at -2, it goes through 2, so at 45 degrees, and definitely in this direction, but we don't need this direction, it can be ignored. And also for this clock, also at 45 degrees, so it also passes through 0 to this point, and also in this direction, but we don't need this part. And you can see that for moving reference frame for A, you can see that light from this clock arrives at this moment of time, T1 primed, and from clock 1 at this moment of time, T2 primed. And then, hence, this is required time interval between two light signals from clock 1 and clock 2. B. At event E, spaceship P leaves S to intercept spaceship A. The speed of P is 0.5 C in the reference frame of S. Identify with the letter X on the diagram the event of P intercepting A. So it travels at 0.5 C. Again, it must be what? Tangent to be 0.5, tangent opposite over adjacent, and we can see that since it starts at this point, tangent to be 0.5, you can see that it will be this point, so it travels in this direction, so that tangent of this angle theta is 0.5, because you can see it's 2, it's 4, and it's quite clear that point of intersection is here, and for S, it's not moving reference frame, we need what? We need just letter X, and then state in seconds time for clock 2. So it's here, it's X, and you can see since clock 2 is in not moving reference frame, you can see that for clock 2 it's moment of time which is equal to what? 8. But what is 8? 8 is CT and in kilometers, and we need just convert this value into seconds. How to do that? It means that it's CT and is 8,000 kilometers, and to get T it just divided by C, and just using a calculator it becomes 2.7 times 10 to negative 5 seconds. The next, spaceship A then returns to S. The space-time diagram shows the rest frame of A on its outward journey and on its return journey. An observer in A determines for the reference frame of S the time t1 immediately before the change of velocity and t2 immediately after the change of velocity. Identify lines and labels on the space-time diagram the difference between t1 and t2. So it's for A, it's for this slant coordinate system, and we need a time in S. So we draw a line parallel to this x primed. Why? Because it's for this slant or moving reference frame for A, and to get a value in not moving reference frame, it just line parallel to x primed, and it's this moment of time t1, and immediately after it just this point but parallel to this, it's t2. And difference, definitely difference is this time interval. And explain how this difference between t1 and t2 arises. It's because A has changed from one inertial reference frame to another when it changes, when it changed velocity, or we can say just due to acceleration at turnaround. Definitely at turnaround there is a force, since it changes direction, and force implies acceleration. To change direction there must be a force, And that's all for this question.